8.2 interior and exterior angles. The angles inside a polygon are called the interior angles. Hopefully that's not a surprise, given that interior refers to being inside. So they are marked the angle I below. So these angles that are highlighted are all the interior angles. The angles marked E, they're called the exterior angles, and they're all outside the polygon. Now the thing about these angles is the interior and the exterior angles are all on the same line. So to form the exterior angle, you extend the lines forming the angle. Now it's really important whenever we're making these exterior angles that we all go in the same direction, so we don't have a mismatch of angles. So these angles E are all formed in a clockwise direction, and what we wouldn't do is then form them in an anti-clockwise direction as well. So we wouldn't say that this is angle E. Now, whilst it is the exterior angle and it's the same value, there's an important fact that we'll come to later on about exterior angles. So whenever we're marking them all on, we would all go in the same direction. So we either go in a clockwise direction or we go in an anti-clockwise direction. So the angles outside a polygon are called the exterior angles. They were marked E, and we could see that each exterior angle and interior angle was in a straight line, so they add up to 180 degrees. In a regular polygon, the interior angles are all equal. Therefore, if the interior angles are all equal, the exterior angles are also all equal. So to work out the exterior angle, we do 180 minus the interior, or if we were wanting to find the interior, we could take the exterior away from 180. So example 1, find the size of angle P. Now what we know is the interior and the exterior add up to 180 degrees. So the angle on the other side of the 110 degrees, they add up to 180. So if we do 180 minus 110, we get 70 degrees. So the angle in here is going to be 70. Now similarly, to work out the angle on the other side of 70, we do 180 minus 70, and that gives us 110. So this interior angle is 110 degrees. So what that's helped us to work out is that we've now got a quadrilateral, and we know the angles inside a quadrilateral add up to 360, and we know 3 of them. So once we know 3 of them, we can work out the 4th one. And because the angles add in the interior and the exterior angles add to 180 degrees, we can work out what P will be. So we need to do 90 plus 110 plus 70, and we get 270 degrees. So then 360 minus 270 is 90. So the angle inside the polygon is 90 degrees. And then because they fall in a straight line, if we do 180 minus 90, that'll get us P. So that means that P is equal to 90 degrees. So the following are very important formula when relating to polygons. The first one, the sum of the exterior angles of any polygon is 360 degrees. So no matter how many sides the polygon has, the exterior angles always add to 360. For a regular polygon, each exterior is found by doing 360 degrees divided by the number of sides. And then similarly, the number of sides is going to be 360 divided by the exterior angle. So if we consider a polygon, so let's start off with a quadrilateral. And what we can do is, if we were to mark on all the exterior angles, then what we've done to get from the first angle all the way around, we've turned through a full revolution. Now one of the ways we can clearly see that is if we zoom out. So I've got the shape centered, and I'm going to keep zooming out, and every now and again I'm going to extend the exterior angle lines, and I'll keep zooming out, and what we can see is essentially all we're left with is these 4 lines that look as if they are around a point. Now at the middle of it there is a square, but for all intents and purposes we've got all the angles about a point. And the same can be done for any shape. So we could draw on a pentagon, and it doesn't even have to be a regular one. We'll draw on the exterior angles. And if we just keep zooming out, then what we'll get is this spiral effect, where all we're left with is essentially, it looks like we're just angles about a point. So all the exterior angles add to 180 degrees. So example 2, find the size of each interior angle of a regular polygon with 8 sides. So what we can do first of all is we can work out the exterior angle. So the exterior angle is equal to 360 divided by n, where n is the number of sides. So in this case it's 360 divided by 8, and that's 45 degrees. So the exterior angle of this octagon is 45 degrees. So then the interior angle is going to be 180 degrees. The interior, yes, is 180 minus the exterior. So that's 180 minus 45, which is going to be 135 degrees. So the interior angles are all 135 degrees for a regular octagon. Example 3, find the size of each exterior angle of a regular polygon with 6 sides, so a regular hexagon. So we've got our hexagon, and we're looking for all the exterior angles. And to work that out, it's 360 divided by n, which is 360 divided by 6, which is 60 degrees. So the exterior angles of a regular hexagon are all 60 degrees. And if we wanted to, we could work out the interior as 180 minus the exterior, which is 180 minus 60, which would be 120 degrees. So all the interior angles are 120.